Rona.
Thank you.
You're welcome.
So, well, welcome everybody. Thank you for making the time. I hope it's going to be interesting. I'm actually embarrassed by the fact that I am a director of design operations, which means that compared to all the other people that have been talking in here who make things, I help people that design things that other people make. So at best, I'm third removed. I'm a cousin to the actual making. But what I'll try to do here is explain you a bit of where we come from, why we're interested in digital manufacturing and new advances in that field, and finally, maybe ask an open question, because if you can help me out with that, that would be great. That would have paid the trip to Barcelona to understand, because it opens up a lot of questions for me and my work these days. So I'll start off with our origins. I can see it there. We were founded in 1924 in dark ages of European history. This is a guy that built it all. He's called Adolf, which is a name that got a bad reputation pretty soon after this. And he founded a company from a cobbling background. He was smart enough to recognize the fact that sports were starting to be a thing in the context of society. This is where you had a lot of unemployment, people coming out of the war, lots of energy, not a lot of things to do after in 1924. So he saw a business opportunity in there. That's when sports started to be popularized as opposed to an elite thing where noble Englishmen would play cricket. This is where we are. We're in the middle of Germany, near Nuremberg. And, well, it's an interesting thing because from there it started to expand across Europe. We're very centrally located. But we decided, and that tells you something about who we are and how we work, we decided in multiple points in our life to stay in a small countryside town of 12,000 people and not move to places which could be more interesting, like Munich or Hamburg or Berlin. We decided to stay close to our roots. Roots that show up in products like this. This has been running for, I think, 37 years now. I hope you all own one. I do own a few, obviously. Or things like this. Again, a historical shoe that's making a comeback, and you see pretty much everywhere you go these days. Or things like this, which is what people draw when they think of football boot. If you go searching for an icon for a web app and say football boot, this is what you get. This is what we do. But we're not tied to our roots that go so far back. We're very well connected to the present because we do things like this, where you're connecting new technologies, chemical technologies on the bottom unit, on the sole, things that come from German chemical manufacturers, probably showing off around there, and giving you a bounce when you run that's far higher than anything that has been done before for a far longer time. And the technology for the upper that comes from computer-controlled machines that knit your shoe together. It happens like this because you can make it stylish as well. You don't run much in this, but it does work. Or you start to move in completely new, fascinating realms of 3D printing and knit uppers, where machines do the job of hundreds of people. Shoes that are built in a way that's completely different from anything that's happened in the past, but you can still run in, because this is actually a shoe that if you can afford it, and if you can get one, because we made only a few hundred and they cost a ton, but you can actually run in it. Some people say it's heavy, but I don't know. So why is this interesting? If the clicker works. The roots of what we do are interesting because compared to everything that's going around in this hall, our process is still very manual. This is a typical sketch for a shoe. A shoe is born this way. It's born from a pencil and the hand and the brain of a designer. This is probably a tennis shoe from a couple of years ago. And even when you prototype, forget 3D printing. The best way you can prototype a shoe is take last year's shoe, cover it with tape, and draw on it. And by the way, it takes all the trouble out of making it flat again, because all you do is cut the tape and spread it out, and voila, 3D to 2D. And even when you do that, the shell patterns are like this. This is how a shoe is born, because shoes are mostly done with flat things that are then cut and sewn together and bent until they look like a shoe. This is where we're all born as cobblers. This is what Adidas was used to back in the 20s. Another thing that we're very proud of, and you've seen it in the pictures, I don't know if it pops up again. This is him probably at a later age. This is not 1924 anymore, Toto. But there's an obsession with making the right product for the athlete that we have. And this goes to a legend that runs around the company, Adi. Gave a lot of trouble to an equipment manager for a football club because he cleaned the shoes. And this is the iconic photograph of him checking out how does a shoe work. And the reason why he gave trouble to the equipment manager was that he'd taken the mud off the shoes that people had been playing with. That's your data-driven design. He was watching how mud accumulates on the studs of a football boot to understand how you can make it better. Now, obviously, that is a process that we're still tied, and all of our 650 designers are born in that tradition, and very often they're coming from that type of school of thought. It's a very analog, narrative, not necessarily data-driven point of view of how you make things. And to encourage that, we topped it off, because we know that there's a lot to be said for making things on your own. And that's why we opened up an internal maker lab where people can go and they can prototype shoes. This is actually a graphic designer learning, I think, how to make shoes. From the amount of shoelaces on the table, it's probably a shoe. But you can't tell right now because he's a graphic designer. And this is a way very often, if you want to go to the core of how you make apparel, you start with a piece of cloth and you wrap it around it. I know that there's apparel designers in the audience. I hope I'm not saying too much wrong here. And even when we do courses on digital tools, we go back to our roots of making things with your hands in a very analog way. So this is a course, 2 pictures of a course where we taught people how to use 3D software for apparel, stuff that could look like very engineering and very involved. As a matter of fact, we had to balance those 2 aspects. And that's where we come from, the traditions that we have. So the questions that one might ask is, why the hell is such a company that's rooted in craftsmanship? And you could almost say that's something that you're never going to move away from. The reasons why we get into this are quite simple and practical. Number 1, performance. We do things that make athletes better. We are striving to make sure that every one of you can get their best out of their performance, whether they're running a marathon or they're 30 minutes running around the block. And performance often comes from places where you can't do things manually. This is a close-up shot of a butterfly wing. Butterfly wings are among the most performing things existing in nature and aircraft. And you can't design such a thing by hand. And therefore, you're forced to pick up computational tools to understand how you turn physics into product. Nature takes time and a lot of sex to do that. We only can take time. But you end up with things that not only perform well, but they look amazing. So there's an aspect that we're all used to in evaluating how performance tries to connect with nature and then make things look eerily beautiful and sometimes familiar, but not exactly in the right way. And Dassault, who's an aircraft manufacturer, used to say that if it's ugly, it doesn't fly well. It's probably true of things. So how does that turn into us? For us, for example, I hope the clicker works, it turns into using computer-controlled stitching machines to place stitches exactly where you want them based on parameters that come from data analysis, or in some cases tradition as well, that's not too bad either, to make a shoe strong in exactly the right place and soft in exactly the other right place, so that you can do the things at the right level, millimeter by millimeter. And that is something that no human can do alone. And that's something that makes us want to get into the space of computer-aided manufacturing, even in areas where things are very traditional, very labor-intensive, and very been the same for a long, long time. The results are things that you can actually wear. This is not a result of that process. This is shoes being tested in Herzogenaurach in 1974 or so. But the idea is you make things through computer that will perform better. This kind of cell-shaped outsole didn't exist at the time. It was exactly the same type of process of figuring out how new technology could improve performance. That's the number 1 factor in why we're getting into these kind of things. Number 2, customization. We all run. We were, apparently some people say that humans were evolved to run. That's the way you hunted back in the days. You ran until your prey fell down. That's why we have brains, some people say, because we can run longer with a brain that only works half. But as a matter of fact, it gets really complicated, and we do have a wealth of data connecting what we see and what we do on a daily basis to what is really necessary in something that is an extremely complicated piece of hardware. The foot is subject to really high stress. It's a really complicated thing. It's full of bones. It's held together by rubber bands, because that's what your tendons are. And I tell you because I broke one. And still, you want something that's catered. Every one of us is different in that realm. So what we're starting to do is look at how you can actually, again, place fibers, place tapes through a computer-controlled manufacturing equipment so that where the shoe adapts and flexes and is rigid and so on is tailored to everybody's foot. Lastly, speed. This is where we started back in 1924. I'm not sure the building exists still. I have a hunch that that's our canteen these days, but I'm not completely sure. But as a matter of fact, if you were in Herzogenaurach and you were trying to sell shoes in Berlin and have Jesse Owens wear them, all you did was take a train and deliver them at 6 hours. Today, things are quite different. This is a picture of a typical factory in China. What you notice out of this is not a false perspective shot. There's no mirrors at the back of it. There's thousands of people in a very far away place. It takes a lot of organization and effort to build such a thing and to make it work to the point that it's very rigid and it takes a lot of time to get something back. A normal lead time for a shoe is if you order it today and you tell the manufacturer to make it, it will come back here in 5 months. That's a ton of time with changing fashions, changing needs. And even you have to specify it down to the size and know exactly how many people wear 8.5 or 9. And if you don't get that wrong, you're stuck with the inventory. And all these people have worked for nothing. So what we're trying to do is move to a completely different approach to manufacturing. We're starting to bring back factories to Atlanta, Georgia, or to close to Herzogenaurach, Ansbach. They all end in these places. And to build shoes in a really short time, very close to where the consumer is, so that you can respond immediately. You don't have a lot of waste and time between when you make things, when you want things, and when you make them. So we're building them with a lot of effort, a lot of support from different angles, but these are completely automated factories that take materials and spit out a shoe on the other end. That's the third topic. And now this is a part where you do homework, because what next is what haunts me in my daily life. Because in my job, I have to help designers design things. I help them with new technology. I help them with new ways of approaching things. And therefore, I'm moving them to higher level of technology in 3D, for example, adopting completely new tools like Grasshopper or Rhino for footwear, people that are used to sketching by hand. And the problem with me is actually that I'm convinced that we haven't changed much since this. I am still convinced that the brain-hand connection is probably the best creative tool that I can imagine. You're probably a designer because you're nodding. But without being a designer, I realize it myself in building PowerPoints. And there's research that says that the more technological the tool that you use for creative work, the more you go deep searching instead of breadth searching. You don't get good ideas, you get a lot of improvement on an idea. So that's a conundrum that I have. We haven't moved much from there, where you sprayed your hand on a wall of a cave. And we know that sketching by hand, this is Edison's sketch for God knows what. I think it is not a light bulb, but it's got to be some other invention that he made. Sketching is a very easy tool to use to actually talk about your ideas, talk to yourself about ideas, and think of whether it's really going to work, doing the right thing instead of doing things right. But as a matter of fact, and sorry, I forgot about this slide. This is, again, a sketchbook of a designer. You see how many iterations of a product he's done before he got to a tape shoe, same as I showed you before. And everything that we do these days, however, is geared towards things that look like this. This is for those of you that use it as Grasshopper. It's a Rhino plugin that helps you design shoes like the one that you saw at the beginning, the one with a 3D printed shoe. This is not a tool for immediacy, and it's not a tool for immediately understanding whether things are right. And my job is actually to make people work well in the creative environment. So I'm stuck. And I thought, when I come here, what do I have to tell? Well, I have to tell a few things, but I also have to ask a group whether they have better ideas than mine. We are trying to build things that are simpler. This is a tool that we're building to design shoes in a very simplified way. It takes out all the hassle of figuring out how big it should be, how the curves are, and so on. It simplifies things to death, but it still will not do things like this. And so instead of leaving you with an affirmative point of where we are, I can tell you all the things why we should get into this, all the reasons why it's interesting for the consumer, it's interesting for a competitive market, it's interesting to do good things in general. But we'll have to all think probably about the human aspect and how does it relate to creativity and to our brain and to our nature in order to do a good job. And that's all I had to do today.
Thank you very much, Simone.
Thanks to you. Thank you, everybody.